you're on.
Okay.
Hi, George.
Hello, hello. This is significant because this is the first lecture, the first workshop, instructional whatever, at the headquarters of the National Cave and Karst Research Institute. So we are in the official classroom where all the stuff's going to happen. Caveats in terms of what I'm going to talk about relative to the cave. I've never been to the cave. I think everyone knows that. What I know about the cave is what I've been told, the maps I've seen, my knowledge of geology of the area, karst hydrogeology in general. So all that, you know, I could easily be off on stuff because if I got into the cave and took a look, you know, I could easily change my mind on some things, but maybe not too much. We'll see. What I want to do is start off by talking about some basics about how caves work and apply that to this cave. And so I'll be drawing and using some maps to do that. So there's two basic ways I see that this cave would have formed. And I'll stick with the more traditional method of cave development. And that is basically you've got water sinking into various locations. And as the water sinks down into these fractures, it dissolves them open, creates sinkholes, and the water drains off somewhere. And as it drains off, these things link together and form a dendritic type stream system. And so this is the traditional model of how most caves tend to form. Now, in our case here, and then it would come out of a spring, and the spring here is basically at the contact between the Edwards limestone and the Glen Rose down below. The Glen Rose in this area is not permeable, and so it forms the base of the Edwards aquifer up on the part that's up on the Edwards Plateau. So the part that's kind of puzzling for me about this area is that while we've got this basic picture, and we've got, you know, and as you go further downstream, of course, the passages get bigger because they get more water that comes into them. What ends up happening is you oftentimes have a fairly longish section of conduit that has few or small tributaries. It's not always true, but it's not unusual to see something like this. Up in this area, you have a contributory system where everything's contributing. It's also not unusual down at the end to see a distributary system where the water splits out between 2 or 3 different passages, adjusting to base level, which in this case is what's at the east Frio that runs down through there. And as the Frio cuts down, the cave will adjust its gradient, trying to keep pace with that river, and so you'll have a little distributary system. And again, that's fairly common. The part that bothers me about the cave is that we've got a fairly long piece here with no real tributaries. Now I know that we've got here Dallas skylines, and know that there's that some water has been found coming in here. I know that for a long time people have been saying that the amount of water in the cave isn't really matching what's seen further back in the cave. In a sense, for what I'm going to discuss right now, that doesn't matter. And if I forget, remind me later on. But I'll talk about that, you know, at the very end. But what I want to focus on though is 2 major concepts for the cave, and this is the one basic concept. And so if we go to the map here that Kurt made, then what I expect would happen is that this segment here is roughly here. Let me move this around. Probably really screwing up with the camera here. But this segment here is maybe roughly equal to this segment here. And as we go further up into the cave, we'll be up into the headwater, and so we'll start, you know, collecting water from here, and we'll see the cave branching out. So potentially we're looking at the recharge area for the cave is up here between the headwaters of the Medina, the Frio, Paint Creek, and the Guadalupe River, Savinal. And so all of this may end up branching out and coming into the cave. Now, one of the big frustrations, of course, caving-wise, is that the water's going to be coming through cracks and small conduits, passages that we'll never get through. So the drainage area itself will be bigger than what we will ever be able to fit into. But it does at least give you an idea of some of the potential. Now, the problem I have, we're not talking about personal problems, is that this just seems really a long segment based on what I know of caves in general, what I've seen of caves in the area. This is really a long segment without having any tributaries. And so, in trying to explain that, it gets a little bit difficult. It gets troublesome. On the one hand, I could say that this is a very old feature, and that might mean something. But if it was an old feature, let me move the topo map here into play. Well, we see that the cave basically goes under this creek, but we've got these high areas around it that should be capturing water from these high areas, little sinks and what have you up here, that should be feeding water in. And I'm not seeing that, or at least I haven't had a chance to look at the survey notes yet. So this bothers me. This is really a long section of cave without any significant side passages. So the other idea of how the cave formed is through piracy, groundwater piracy. Because, as I'll explain in a minute, long passages with few or small tributaries is a real good indicator of groundwater piracy. So let me just give you some basic concepts on that before I go too much further. Let's see, and this will be a diagram you guys just saw yesterday. Let me just draw the system here where we've got, should have drawn that in black, but now I'll just use a different color for water. Okay, we've got, let's say, two cave stream passages. They can be parallel to each other, they could be, at different angles. It really doesn't matter. But the main thing is that one passage is at a higher elevation than another passage. Well, of course, caves are crossed by a bunch of fractures that go through the area, and as water moves down through this upper passage, what will happen is it will dissolve open one of those fractures and start leaking water down into the lower passage. I've often joked around and said that water is smarter than people. Water tries to find the easiest way to do things. And one of the things that water is trying to do, it's basically driven by gravity. It wants to get to the lowest possible elevation that it can reach as quickly as possible. And so if this is its lowest possible elevation, at least locally, rather than go down this long, long passage to get there, if it can create a shortcut, it's going to do so. Eventually, what will happen is this fracture will enlarge into a passage of its own, and the water flow through here will be completely pirated down below, leaving an abandoned passage up above, at least hydrologically abandoned. This little section of passage is known as a tap-off passage. Some of the characteristics of a tap-off passage is if you catch them when they're fairly young, they tend to be small relative to the amount of water that they're carrying through, because the amount of water is meant for this size passage, not this new passage. Another characteristic is that they tend to have few or no tributary passages because they're a very young passage. They haven't been around very long. They've got a lot of water pushing through them, and they're not as old as these passages to develop tributaries feeding into them. So when I see something like this, you know, one of the first things I think is this may be a tap-off passage, because it's a very long passage with few or small tributaries. Now, also as I've drawn this, one thing to keep in mind is I've drawn this as two passages. This could be a surface stream and a cave passage. This could be a cave passage and a surface stream. This could be two surface streams and a cave passage. So it's the gradient that's really driving it. A real good example of this being two surface streams in the cave passage is Prassel Ranch Cave, not too far from Cave Without Name, where the Guadalupe River makes this bend like this, like that. And in Prassel Ranch Cave basically cuts halfway across that bend. It's about 2.5 kilometers long. And at one point, you know, and it's basically plugs with mud and gets low at the end. But this is, you know, this formed by pirating water across that meander loop, and then the Guadalupe River cut downward, abandoned flow through the cave, and now you'd have this cave with just a long cave with a trickle of water flowing through it. But this cave was a tap-off passage. Again, no side passages to speak of in Prassel Ranch. So, is this a piracy cave? Is what we're seeing of Perry Water Cave a tap-off passage? Well, Kurt sent an email saying, all right, well, if it's formed by piracy, where is it pirating its water from? Okay, so let me draw a different picture and tell another story. And this is part of my email to Michael, where I was talking about streams throughout the area. If we look at the geologic history of the area about 12 million years ago, or let's say 20 million years ago, we had rivers like the Guadalupe flowing roughly from west to east, the Medina flowing roughly from west to east.